Hello everyone. Today I'll be presenting to you Golang and concurrent programming. So what is Golang? Go, also known as Golang, is an open source programming language developed by Google in 2007 and officially released in 2009. It was created by Robert Geismer, Rob Pike, and Ken Thompson with the aim of improving programming productivity in the era of multi-core processors and large-scale distributed systems. Okay, here are some of the features of Go. First is simplicity. Go was designed to be simple and easy to learn with minimalistic syntax and a small set of language features. In fact, if you look at Go code from, say, 10 years ago, it would still be very much similar today, even though it has already been 10 years since, because the creators of the programming language itself uh, did not add much feature just to keep it as minimalistic and as simple as possible. Okay, Go is statically typed, meaning variables must be declared with their types at compile time. This helps catch errors early and improves code reliability. Okay, Go comes with a rich standard library that provides support for common tasks such as networking, file I/O, cryptography, and more, enabling developers to build robust applications without relying heavily on third-party libraries. Okay, Go programs can be compiled to run on various platforms, including Windows, Mac OS, Linux, and more, making it suitable for developing cross-platform applications. Okay, and lastly, concurrency, which is the center of my report today. Go has built-in support for concurrency through Go routines and channels, making it easy to write concurrent programs that utilize multi-core processors efficiently. Okay, so since we're talking about concurrency, I think it is important for us to understand what is concurrency. Okay, so concurrency is like juggling multiple tasks at the same time. Instead of focusing on just one thing and finishing it before moving to the next, for example, a synchronous execution, instead of that, you handle several tasks simultaneously. So each task progresses independently and you switch between them as needed. So to understand more about how concurrency works, let's think of a scenario where we need to cook multiple dishes simultaneously. And let's assume that these are the steps needed to complete a dish, right? So preheat the stove, gather ingredients, prepare ingredients, cook the dish, prepare the dish, and then serve the dish. Okay, so here we can see we have a time arrow here just to visualize how long it took for us to complete all the dishes. And of course, we have the chef here. Okay, so first is we preheat the stove, and then while the stove is preheating, you gather the ingredients for the first dish, and then you prepare the ingredients for the first dish, and then let's say somewhere around this time, the stove is already preheated, so you are now ready to cook the first dish, and so you cook the first dish. Now, while the first dish is cooking, right, you can now start gathering the ingredients for the second dish and then prepare the ingredients for the second dish. And let's say somewhere around this time, the first dish has finished cooking. So what you do is you take it out of the stove and then you put it in the pot and then prepare the first dish. Okay. Now notice that since the stove is now available, you can now start cooking the second dish, right? And then while the second dish is cooking, you can now start serving the first dish. And then let's say somewhere around this time, uh, the second dish has finished cooking. So you put it in a pot, prepare the dish, and then serve it. Okay. So here you can see how concurrency works, right? You switch between first dish and second dish as needed, and each tasks are progressing independently. Okay, so concurrency is actually often confused with parallelism. So I think it is also important for us to understand how parallelism works and learn how they differ. Okay, so what is parallelism? Parallelism is the execution of multiple tasks or processes at the same time. Okay, so unlike concurrency, where you execute tasks simultaneously by switching between them, in parallelism, you actually execute tasks at the same time. So it's like having several workers tackling different parts of a job all at once, instead of one after the other. So let's look at parallelism uh, using the same scenario as before when we cook multiple dish at the same time. So this is how it might look like. Okay, so obviously you can see here that the dish one and dish two are being cooked at the same time. So they're being cooked in parallel, but there are a few differences here as well. First is the stove. Okay, now the stove is bigger and it has more capacity. It now has two burners, so it is now able to cook two dishes at the same time. Now, aside from that, to maximize the capacity of your bigger stove, you would also need to have another chef. Okay, so now two chefs are cooking two dishes at the same time. So that's how parallelism and concurrency are different. Okay, so since we are focusing more on concurrency, let's look at how Golang handles concurrency and how can you create a concurrent program in Golang. So enter Go routine. So what is Go routine? A Go routine is a lightweight thread of execution in Golang. Okay, it's like a small independently executed function that can run concurrently with other Go routines within the same program. Okay, so to create a Go routine, all you need to do is to add the Go keyword before a function. Okay, so just like the example code here, where you created a function greeting, right? In your main function, you call the greeting function normally without the go keyword, and then also you are executing it with the go keyword before the greeting function, which will in turn run this function concurrently. Okay, so let's actually try this code. Here in our IDE, we have similar function, or we have similar program. We have a function greeting, which takes in a name string and then prints hello and the name. Okay, so here in our main function, let's actually call that function and add foo as the name. Okay, so let's try to run it first. Okay, to run your Go program, you need to say go run main.go. Okay, main.go is the name of the file where your main function resides. Okay, so let's try this and see what happens. Now you are uh, seeing a hello foo in our console. Now, I'm sure you have noticed that we are not actually running this concurrently. Why? Because we did not put the go keyword in front of this function, right? So to do that, let's just simply add the go keyword. And now this function is a go routine, meaning this will now run concurrently. Okay, so let's try to run this again. But here you see that it doesn't seem to print anything in the console. So what's wrong here? What's actually happening is that the moment you added go keyword in front of a function, you're actually telling the Go runtime that this function, I want this function to run independently of the main function. So what that essentially means is main will no longer wait for this function to finish. Instead, what main will do is to execute the next line of instruction. Okay. However, the problem here is that in our particular example, there's no longer uh, other instruction after this line for the main function to execute. So therefore, since there since there's no more instruction to execute, the main function will now terminate. Okay, so the main function terminates even before the greetings function had the chance to execute itself by printing hello name in the console. Okay, so what we can do is to actually implement a time delay. Okay, so let's say time.sleep, and then let's delay the termination of main function for 1 second. Okay, so this is 1 second delay. So let's try to run it. Okay, so now you can see that the main function waited for 1 second before it terminates. And apparently that 1 second is enough for the greetings function to execute itself. So that's why we're able to see hello foo in our console. Okay, so let's dive deeper on what or how Go routines work. Okay, so this is the basic architecture of a Go routine. So we have the operating system level thread, okay, and then in between the OS thread and the Go routines, there is actually a Go scheduler, okay. So what does this Go scheduler do? The Go scheduler decides when and where to execute each Go routine. It's responsible for distributing Go routines across available OS threads efficiently. Okay, the Go scheduler maps multiple Go routines onto a smaller number of OS threads that can run concurrently. And then lastly, when a Go routine is waiting for something, for example, an I/O operation or a time delay, the scheduler can temporarily suspend it and switch to another runnable Go routine. So in our example here, okay, the main function is actually a Go routine. Okay, it is by default a Go routine. So when we implemented a time delay here, okay, it went to the next uh, runnable Go routine. By it, I mean the Go runtime, uh, switch to another Go routine, a runnable Go routine, and then execute it. And by the time that 1 second has passed, execute, go back to main function, and then the main function terminated. Okay, so let's think of Go routine as an employee. Okay, in this particular example, imagine that you are organizing a group of people to work on different tasks in a big office building. So you can think of employee as a Go routine and office room as an OS thread. Okay, instead of assigning one employee or the Go routine for each office room, which is the OS thread, okay, which would look something like this. Okay, you can already tell that this is a waste of space. Why? Because you can clearly see that an office room can accommodate more than one employee. However, you're only assigning one employee for each office room. Okay, so of course you can have multiple office rooms, and despite that, you only assign one employee for each room. So instead of this, what Go routine does is actually, okay, the Go scheduler assigns multiple employees or multiple Go routines for each office room. So remember, the Go scheduler is the one that maps Go routines to each of OS spreads. Okay, the scheduler, just like a manager, keeps track of who's working on what and makes sure that each room is being used efficiently. Okay, so that is why Go routines are actually considered as lightweight because you can assign multiple Go routines for each OS threads. This is very much unlike Java. If you have experience in Java threads are actually assigned for each OS thread. So this is how Java threads actually looks like. Okay, so one Java thread is assigned to one OS thread. So that's why when executing a a multi-threaded application in Java, you would need more resources. But in Golang, since Go routine is lightweight, you don't need much resources compared to Java. Okay, so let's look at more example of Go routines. So let's look at how we can create a function that can count from 1 to 10 and then run it concurrently. Okay, so let's say func counter. Then I would like to add an ID which is of type string, and then perhaps an interval type int. Okay, so I want to count from 1 to 10. Okay, and then I want to print my ID. Let's say that's percent %s, and then the current count, which is a percent %d. Okay, and then pass in my ID and I. Okay, and then uh, after printing it, I would like to add a an interval before printing another count. Okay, so let's say time that sleep, say time that second multiplied by time that duration, pass in my interval. Okay, so now let's run this function concurrently. So let's make a Go routine out of it. So counter, and then pass in my ID, let's say C1, and then let's wait for 1 second for each print. Then let's add another counter, and then let's name it C2, and then with a time interval of 2 seconds in between prints. Okay, so again, this is not going to work yet because the function main will terminate prematurely. Okay, so what we can do is again can add a time delay here, time that second multiplied by, let's say, 20 seconds. Okay, now in this example you can already tell, right, that this solution is actually not scalable. Well, this works, but this is not scalable. Why? Because for this to work, you would need to know how long it would take for all the Go routines to finish their execution. Say, what if I would add a couple more Go routines here, right? So I would need to know how long it would take for all these Go routines to finish their execution, and then I would, based on that, I would specify how long I would want to delay the termination of main function, right? So this is not scalable solution, okay? This is not scalable. So another solution that we can do is, so let me just comment this, is to add a for loop here, right? Now this for loop is actually an infinite loop, and the Go compiler is actually smart enough to know that this is an infinite loop, okay? So it tells you that this is an infinite loop because you are not passing in any condition, okay? But since this is just a warning, this would still compile. So let's just try this. Uh, this is just temporary. Okay, try to run our program first and see what happens. So now, uh, C1 and C2 are actually running concurrently. Okay, they are both running at simultaneously, and C1 has just finished counting, and C2 is just about finished as well. But here you can tell that our program is still running. Okay, the reason is because we have a for loop here, which means our program is just going to run infinitely. So this is not good because uh, this is not memory efficient at all. So what we can do is, in fact, the best solution here is to add a wait group. Okay, when dealing with multiple Go routines, you would need to add a wait group. So how do we do that? Okay, so to do that, let's say wait group is equal to sync that wait group. Okay, now a wait group needs to know how many Go routines are we going to wait for. Okay, so in our case, we are going to wait for two Go routines. Okay, so let's go add two, right? And now that we have added two Go routines in our wait group, okay, our wait group will now have to listen for our Go routines. It needs to listen when this Go routine or when each Go routines will have to finish their execution. So the way to do that is to add a reference to our wait group, okay, and just simply say wait group dot done. Okay, we can tell the wait group, okay, that we are done executing. Okay, in fact, we can add defer here. So this defer keyword actually just tells you or just tells the Go runtime to execute this function the moment I finish the execution of this function body. Okay, so here in our main function, we can say, or we can pass the address of our wait group. Okay, address of our wait group. Okay, and then uh, this, uh, this is the best solution. Okay, what you can do is you can say with wait group dot done. Okay, so let's try this out and see what happens. So you can see our program is still running. So let me just exit and then run this again. Okay, oops. Run this again. Sorry, not done, but wait. Okay, so see, okay. So now C1 and C2 are counting simultaneously, and then C1 is finished counting, so C2 is still counting, and then, okay, done. All right. So you can see that the moment all of our Go routines has finished execution, our main function has also terminated. Okay, that's what this wait function actually means. So with that, I hope you have learned something from my report. That is all, and thank you so much.